This is Algebra 2, Lesson 13, Substitution and Area of an Isosceles Triangle. All right, one of the things that's very important to know as far as algebra is concerned is when we have an equation with one variable, we only need one equation to solve it. When we have an equation with two variables, we have to have two equations in order to solve it. If we had an equation with three variables, an x, y, and a z, let's say, we would need three equations to solve it. So what we're going to do is we're going to look at some equations in this lesson that have two variables in it, which means that we are going to need two equations. So if we look at example 13.1, we have x equals y plus 5. There's one equation, but it's got two variables, so I know I'm going to have another one. And what they'll do is they'll do this. And that is called a system of equations. So good to remember that whole thing about systems of equations, because I will use it over the next few years of math with you as we do these. And again, I say years because you will continue doing substitution for years to come. All right, so what do we do with this? Well, first of all, we look at one equation at a time. So we're going to look at this one, and we see that we have an x and a y. Well, if we look at the top equation, we see that x equals y plus 5. So if we took this y plus 5 and substituted it in there, it would look like this. So instead of an x, we're going to put a y plus 5, because I said they're equal. So I can put it in there instead. Now what do I have here? I've got an equation here with how many variables? I just have a y, so I only have one variable. It appears twice, but I only have one. So therefore I can solve this equation, one equation, because I have one variable. So I'm going to use distributive, and then 2y equals 5. I'm going to combine my y's and get 5y. I'm going to subtract 15 from both sides, and I get 5y equals negative 10. Divide by 5, and I get y equals negative 2. Awesome. So now I know what y is, negative 2. I don't know what x is, though. So what I'm going to do is I'm going to look at either one of these equations up here, and I'm going to substitute, that word substitute again, negative 2 whenever I see a y. So I'm going to take the first one here because the first equation looks easiest. So I'm going to use negative 2 in for y, and x equals negative 2 plus y is 3. So 3, negative 2 is my answer there, and I'm just going to put them in parentheses. And the first one always represents the x, the second one always represents the y. So I don't have to say x is 3, y is negative 2. I can just list them as 3, negative 2, and you will know the first one's x and the last one is y. So off to another one. We have 3x minus y, and we're saying that equals 11. And we have 2x plus 3y, and we're saying that is negative 11. Alright, so the problem with this one, I got to put my little squiggly. The problem with this one is we don't have anything that says x equals something or y equals something. So what we have to do is we have to move things around, manipulate things around so that we get y equals something or x equals something. It doesn't really matter which one you choose to set, whether it's y or x, or which of the problems you do that with. Let's do the top one, and let's set it equal to x. So we're going to look at this one, and we're going to take 3x minus y equals 11, and we're going to set it equal to x. So let's get it by itself. We're going to move the y over, and we're going to divide by 3. So x equals 11 plus y over 3. That does not look very pretty, because what we're saying is now that we have this, we're going to take this and take the bottom equation and put that in its place. Yuck. I don't like that at all. I can do that and it will work, but it might be easier if we were to get rid of this and try another one. In fact, let's go ahead and let's solve it for y. Let's take the same one and solve it for y instead. So let's subtract 3x from both sides. So I have negative y equals 11 minus 3x, and I divide by the negative. I divide by the negative, or what you can do instead of going through all of the dividing, if I want to make this negative y positive, I just make it positive and change everything in the whole equation to its opposite. So I'm going to change that to y, but I'm going to have to make that negative 11 and that a plus 3x. And then I can do that. Okay, this doesn't have any fractions. That looks a lot better. In fact, I'm going to switch it around to make it 3x minus 11, which you can do that as long as you drag the signs along with it. So now I'm going to look at the second equation here, and whenever I see a y, I'm going to put a 3x minus 11 in its place. Okay, now I have one variable, an x. It appears twice, but I have one variable and one equation. Okay, now I'm going to add my x's. And I'm going to add 33 to both sides. Divide by 11, and I get x equals 2. Okay, so that's good. I've got x equals 2. Now I have to find the y value. So I'm going to look up here at the original one, and I'm going to find the simplest one. Which one is this one looks simpler, 3x minus y. So I'm going to take my x, I'm going to put a 2 in there. So 6 minus y equals 11. Subtract 6 from both sides. Oops, that's not even negative, is it? It's positive because we subtract 6, so 11 minus 6 is positive 5. Now again, I've got a negative y. So to make it positive, I just change the sign of everything else, so that becomes a negative 5. So my x is 2, my y is negative 5, and I write it as 2, negative 5. And that is my answer to example 13.2.